different participants, and definitely it will help us to understand the subject, having more diversity of the participants. So today I have planned to cover the session on tiny machine learning basically. So that is going to be, I'm going to cover for more, maybe for 1.5 hours, or maybe if it is possible and if it is something remains, we will also cover in the next session. So this is one of the very interesting and very important topic of machine learning today, as we faculty are from different backgrounds and having a kind of a different expertise in different areas. This will surely help all the participants. So I will start my session by sharing my presentation. Is it available in the full screen?
Sir.
No, not yet, sir.
Yes, I can.
Yes, sir, it is visible now.
सर इट इज विजिबल बट नॉट इन द स्लाइड शो फॉर्म एटलीस्ट ऑन माय साइड पार्टिसिपेंट्स आपको स्लाइड शो दिख रहा है
No, ma'am.
No, ma'am.
इट इज
Okay.
It is visible, ma'am.
सर एक बार ना स्टॉप शेयरिंग करके फिर से करिए
Okay, now I think it is available. It's good.
यस सर नाउ इट्स फाइन
Yes, sir.
Okay, so thank you, madam, for the introduction and talking about the program. We'll start with the some of the basics of tiny machine learning, and then we'll come to some of the real world examples how we can use tiny machine learning on the edge computing or maybe for the embedded systems. So, okay, we have already, all of us know very well that AI is very dominant these days in all the different domains of our life, and people are using like effectively in terms of whether it is manufacturing, whether it is electronics, whether it is communication, whether it is business or e-commerce, whatever we call, we use AI everywhere. Important thing for us as a faculty that when we are interacting with the students, and specifically when we have students from computer, IT or electronics background, it becomes very interesting that we can use the domain expertise for implementing AI into the hardware or the electronics, or maybe I should call it as a very small device, which has lots of limitation in terms of hardware capabilities, or maybe the processing time, or maybe the memory size, whatever we call, there are lots of limitations. So these days, like most of the computer scientists or the AI engineers are implementing artificial intelligence on the computer itself. So there are various types of different types of data we use. We train those data, we create a model, we implement, maybe deploy on some of the application for the application. So we use computers for that. And we have huge amount of power available in terms of processing those data, training the model, implementing on the machine, because maybe computers are having GPU or a very high-end CPU. But when it comes to transform all these AI applications to a very small hardware, then comes the role of the tiny machine learning. So that is what I'm going to cover today. So why do we use embedded machine learning? Embedded machine learning is simply, in a very simple way, if we implement machine learning on an embedded system, that is what we call as an embedded machine learning. And why it is so much popular these days? All of us know that we have at our home maybe Amazon Alexa device or Google Home or Siri or number of hardwares are available. These all are nothing but the edge computing devices, or I should say embedded ML. Embedded ML kind of a device which we use for computing low power device. And why this is so fast? Like the fundamentals of AI, the mathematics, the statistics behind that, or maybe the linear algebra or probability, and the computer programming languages were already available. But because of last 5 years progress in terms of the computing facility, the storage device in terms of cloud systems, the high-end processor, the implementation of very powerful processor on the embedded system has actually grown given the growth of the embedded machine learning. So basically, we run our machine learning model on a small microcontroller. That is nothing more than that, the embedded machine learning concept. So we call them as a tiny machine learning because it's very small model which we run on the embedded system. And we will see some of the use cases also. This particular PPT has changed the format on this particular my open office. But let me talk about, there is a concept called blurb. It is all about bandwidth, latency, economics, reliability, and power efficiency. So when we are going to run any of the model, when we are going to run any of the model on an embedded system, we should keep in mind that there is a blurb kind of a concept. So whenever we talk about an embedded system, usually there is a problem of the bandwidth, that it does not have that much of capacity to handle those data. Then comes the latency, because whenever we use any electronic system, they are basically the components which add some delay to the system. And whenever we respond, whenever we give some information or the data to the system, it responds after few seconds. So as you might have observed that even today, Amazon Alexa, when you ask, hey Alexa or okay Alexa, at that time it takes a time and it gives you the response. So latency is also very important. We need to keep in mind while designing or developing or working with the embedded systems. Then comes the economic, because finally, whenever we are talking about any business problem, economics is very important. But most of the hardwares are not that much costly like computers, and that is why the economics concept is also fulfilled. Then comes the reliability. The system should be reliable, and finally powerful in terms of the power or maybe the handling the power systems. Now coming to the next slide, we call it as an edge computing, but what is the meaning of edge computing? What do we understand by edge computing? We have heard about lots of different computing systems, but edge is a kind of a different scenario. Take an example of a huge cloud system, what we have in our day-to-day life, like there is a Google Cloud or Amazon AWS services. Number of cloud services are available and we use them. But what we do when we use our AI model to train over there, or maybe we provide the data to these systems, basically we are sending our data to these cloud servers and the data is being processed over there. The model is trained and we get the output of those details whenever we provide with a new data. So the thing is, we are part of the network, or we are part of the network where we are utilizing all the powerful resources. But when it comes to edge computing, edge is basically a word which is when you are on the edge of the network, or maybe this is a very big cloud network, but the Amazon Alexa which is residing in your home, it is at the edge of this network, and the data is not basically stored inside that device. The model is already running, but whatever is required, it fetches from the server in terms of the output for the data. If you say play Kishore Kumar song, so it will fetch only the Kishore Kumar song, but most of the processing happens inside the device in your home itself. So when the devices are at the edge of the network and the computing happens over there, it is nothing but the edge computing, or in different way, it is also known as a physical computing kind of a thing. So these are some of the points I have listed out, that like machine learning models are getting smaller due to development in advanced libraries. Scientists and developers have developed lots of libraries, and thanks to a number of scientists working at the Google, they have actually created a very good concept of TensorFlow Lite kind of a thing, which actually helps you to turn bigger libraries or bigger models into very small models. It actually transforms into a kind of a smaller size. Thanks to the hardware companies who have made all these powerful processors like Arduino, ARM, Raspberry Pi boards are getting more powerful, because these days like we have lots of devices available in the market where you can use those devices for machine learning applications. It is moving rapidly towards edge devices. Like these days, most of the companies in the world are having one department which is exclusively working for the edge computing, or maybe a kind of a embedded machine learning. If you look at Google, if you look at Microsoft, if you look at Amazon, Amazon has Amazon Robotics, which are specifically working in this area. And so it means that now there is a transformation from the huge cloud system to a smaller embedded system, because everybody cannot use, all the time, we cannot use computers for most of the applications. We need a smaller device. AI on microcontroller enables cheaper, lower power and small edge devices. That's one of the powerful thing, like a kind of a wearable watch that too runs lots of machine learning models inside our the wristwatch. So this is the power of the electronics, the power of the IT, the power of computer science, and the power of mathematicians who are able to make all this possible. It reduces latency, conserves bandwidth, privacy, and enables smart application. This is very important these days for every company. Like most of the companies are worried about the privacy of the user, and we must be aware about like privacy criteria, and we call it as a federated learning, which is basically used in IT industries these days. That privacy is the first priority for most of the companies. So when we edge computing devices, we get lots of privacy for our applications. As well as there is no need to use high internet bandwidth, there is no need to use cloud data, and that is why it conserves the bandwidth also. Now, how to start with this? I will directly jump into this because, like there are two different types of concepts of learning, and both the concepts are good for anything when we are planning it for the first time. I call my student that when if you want to learn if you want to learn swimming, there are two options: either read a book how to swim or directly jump into the swimming pool. So the best way is that though you have read lots of books on swimming, but you can never know how to swim until and unless you deep dive into the swimming pool. So to have a quick start on this particular to show you some of the fundamental aspects of these machine learning for the edge computing devices, and then we will see other aspects of that. So what do we need if you are interested in developing some edge computing applications or maybe tiny machine learning? The only thing what we require is a kind of a laptop having a latest configuration, an Arduino. Usually the Arduino Nano is good for this sort of tiny machine learning application. The best one in the market is Arduino Nano 33 BLE Sense. This is a latest one. It is not a normal Arduino Nano.
अटेंडेंस मत समझ में नहीं आवाज ही नहीं अटेंडेंस चैट बॉक्स में डाल दो ना अटेंडेंस
And some editors to write the code. You can use Visual Studio or Atom or any other IDE which you have available. You can use that. And if you have a Gmail account, the Google Collaborator provides you to train the data on the Google Colab. Finally, when the model will be ready, you'll be able to deploy it on the on the embedded system. So in today's session, what I'm going to cover is about like some of the introduction to machine learning. Then there would be about something about transfer learning and classification, how to run a model. Specifically for machine learning applications on the embedded system, we will try to see that TensorFlow Lite and TensorFlow JavaScript or ML5JS are the popular architectures for that. How to train a model, example for gesture detection with TensorFlow Lite, like face and hand tracking with TensorFlow, and some of the sensor data classification. So what we are going to discuss today is that what is possible with microcontrollers in machine learning. See, nowadays, if you want to make a kind of a deep learning application, we use computer, we use camera of the computer, we use video, we use photographs, and we use the processing power of the computer to create any application on the computers. But when we are talking about a kind of a tiny machine learning application, we have a microcontroller. So there are cameras available for the microcontrollers. There are microphones available for the microcontrollers. And the best one is the Arduino Nano 33 BLE, which actually help us a lot to provide all sort of applications which we can do on a computer. We can transform directly them on a machine learning, tiny machine learning based applications. So what are the different use cases where we can create this sort of applications? It can be related to speech. Say, for example, I want to create a embedded device or an edge computing device in my home which identifies the family member's voice or the speech. Or maybe if you want to create an application which actually identifies the language of the speaker. Say you are watching TV and you are surfing on different channels, and when there is a channel for DD Udia or maybe DD Hindi, DD Punjabi or maybe DD Gujarati or a Marathi, as a human we understands everything, but most of the time we are able to understand some of the languages only, in terms of we can identify the language, not we are able to speak or we understand those things, but at least as a human we are so intelligent that we can identify, okay, this is the person is speaking Marathi language or the person is speaking maybe Bengali language. These are some of the things which we know. So it's basically a race of human to transform all this intelligence to a microcontroller. How we can do that? So this is one of the use case area where you can develop applications for language identification. Then there is another use case for gesture detection. There are lots of way we do lots of gestures in a day, but some of the gestures have meaning because we communicate with gestures also. If I say bye bye, it indicates that you have a kind of a waving of your hand. It's a gesture. So by identifying the gestures also, we can find that what is happening actually. So these are some of the important use cases we can discuss on that. Another one is related to image, where we do lots of image classification, image identification of the objects from the images. We can do pose detection. If I raise my hand, the computer or the microcontroller will be able to identify that my hands are raised. That is basically the pose detection. And you will be surprised to know that like today, most of the CCTV cameras in US and Shanghai or specifically in China, they are making this sort of pose detection identification from the CCTV camera. So if there are some elderly people in the house and if they fall down, it actually identifies the pose of the person and it alerts immediately to the emergency services. Then comes the sensor data classification, because every day we are generating lots of data, and sensors are basically the huge sensor data provided in terms of generating the data. You may have a temperature sensor or maybe the humidity sensor, LPG, CNG, PNG, alcohol, methanol, ethanol, all these sensors are available. And these days, people are trying to even identify the smell using machine learning. So this is one of the area where we can work on sensor data classification, and even we can upload all these data. Say for example, I'm cycling every day, so I'm generating data also, because whenever I ride, one of my application in my mobile phone is actually collecting my GPS track. It also collects my heart rate. It also collects my distance traveled and various speed variations and number of altitude levels, and everything is basically collected and being generated by these sensors inside the mobile phone. And finally, we have huge amount of data. So if we can process all this data, if we can understand all this data, that is what the job of an AI or a data scientist or an AI engineer. That given huge amount of data, we want to actually identify useful information from this data. So that is what the job of a AI engineer or maybe a kind of a data scientist. So this is one of the book I refer, and I have also used this book to understand the concept of tiny machine learning. It was written by Pete Warden, who was one of the Google employee. Right now, he has his own company, but he has written the first book ever for tiny machine learning with very good examples. And I have a privilege to get the copy from him. So he has sent me a PDF file. If anybody wants this after this session, I will definitely be able to send you. It covers almost all the examples on Arduino Nano to use different sensors for creating the machine learning applications on that Arduino Nano 33 BLE sense. So some of the concepts I will quickly go through, and we know that AI, machine learning and deep learning, but let us see one of the popular image by NVIDIA, which everybody uses while presenting on some of the fundamental concepts. So AI is basically a broader category where we have machine learning basically, and then we have deep learning specifically related to kind of a video or maybe images or different types of audio data. It covers the part of that. So AI is a broader domain. Machine learning is part of that. And finally, we can see that it actually started in 1950. At that time, when mathematics was actually talking about the artificial intelligence, but we didn't have that sort of computing power. We didn't have that sort of cloud storage. We didn't have that sort of very high-end developed libraries in computer science, and that is why the powerfulness of mathematics was still there, but we were not able to use them. But because of this development in all these different domains, we are able to utilize those power today in our most of the applications. So as I always say, AI is not the branch of computer science, IT, electronics, mathematics, but it is the subject for all. It basically a kind of a branch where we need to have some sort of fundamental understanding. Say for example, I'm a businessman. I want to do some sort of um, make some profit more into my business. I can definitely go to the data scientist and I can ask them to increase my profit by analyzing my sales and marketing details and number of different parameters from my data. If someone goes to a mechanical engineer might have lots of different data for manufacturing, or maybe he wants to do a predictive kind of an analysis that or maintenance kind of a thing. It is possible. So this is a kind of a basic branch for everyone. It depends what domain expertise you have and how do you want to use it for your application. So the human race is basically to transform human intelligence into the machines, and that is why human intelligence exhibited by machine is nothing more than what we call as an AI. And machine learning is one of the approach to achieve the AI is basically using the field of computer science that uses statistical techniques to give computer system the ability to learn with data without being explicitly programmed. Usually in past we provide the data and finally we were programming those data and we were getting the output. But now it decides how I need to learn from the data. If you are given some of the information or the data, how a human intelligence actually identifies the output from the data. Similarly, we try to see that the computer acts like that only. And machine learning is a technique for using computers to predict things based on past observation. Let me give you an example that say I want to create a system by which I want to identify the result of a student just by looking at the face of the student. Is it possible that I can find and fetch the details of the student result? Or maybe a supervisor is supervising in the classroom and just by looking at the face of the student, by having a wearable AI glasses, the faculty will be supervisor will be able to identify the credentials of the students. That is also possible. Even by just looking at the number plate of the car or maybe any vehicle, the traffic police can identify whether the vehicle has actually paid the insurance or not. These are all possible things which we do using machine learning. So this was a very popular image which everybody uses for talking about AI and ML. Traditionally, we use computer as a central computing device and we were providing data and program and we were getting the output. But here we provide data and output because output we know in terms of what we want from the algorithm. So this is a kind of a different scenario of both the traditional programming versus machine learning programming concept. Deep learning is basically a technique for implementing machine learning in a different way for images, videos, etc. It uses multi-layered artificial neural networks to deliver state-of-the-art accuracy. Uh, those who are very new to the artificial intelligence, let me tell you that the human brain is made up of lots of neurons, and neuron is the single unit of our brain. Similarly, the scientists have created an artificial neuron, a kind of a structure in a program by which we are able to program these neurons, or maybe we are able to use the power of this artificially generated neural network to get lots of useful information out of that. It can automatically learn representation features from data as images, videos, or text. A very simple example to understand the concept of how the human intelligence work. Whenever we see something, actually our brain does not see anything, but our eyes sees all these things. And that is why the reflection of the light reaches to our eyes, and on backside of the eye, we have a kind of a visual cortex which actually transforms the information to the brain, and the brain understands. But as a human, we never remember anything, we do not capture any images, we do not store any of the images into our brain, but a kind of a useful information which has been extracted. Say for example, right now in front of my eyes there is a monitor, there is a camera, there is an LCD device. So my brain has not any storage in terms of that this is the monitor, this is the camera, but it actually stores some of the information in the form of AGs or maybe a kind of a shades of different colors, etc. And finally try to identify, because over a period of time, when we are born and we grow up, we learn lots of things and we understand. So we have already a trained model which is still being trained day by day. Every day the model gets updated and finally we get more and more stronger in terms of intelligence. And that is why we use our intelligence to identify anything. If I show, say this is a what is this? If I ask you like, what is this? So most of the people will say that it is a mobile phone, but nobody will tell that it's a black rectangle or maybe a kind of a glass rectangle or maybe a kind of a frame. Nobody will even call it as a communication device. Why? Because human intelligence is so powerful that we try to predict it up to maximum level, maybe up to 99% of accuracy. And if somebody is so much accurate, he will be able to say that, okay, this is a mobile phone, but it is again an Apple phone. So that is what the human intelligence is all about. And that is what the race to transform this intelligence. So what we do actually in terms of understanding these concepts, that whatever we have gained in terms of our intelligence, we try to replicate the same concepts. Say, for example, there is a fruit called dragon fruit available in the market. I think it was not available maybe 10 years back in the market. So, if we ask ourselves, were we aware of this particular fruit until and unless we saw it for the first time? Or maybe when we saw it for the first time, we had no idea what the name of the fruit is. But definitely the human intelligence of ourselves was so strong that it is in the category of some fruits. So that was our intelligence. We were able to classify this fruit as a kind of a type of a fruit, but we were not able to know the name. But nowadays it is available everywhere in the market, and that is why we are able to identify that, okay, this is a dragon fruit. Now, if some another new fruit comes into the market, we will not be able to identify because our intelligence is not up to until get the data in front of our eyes. So that is what the concept, what we are trying to use in machine learning. So this is a very simple example of an artificial neural network where talking about deep learning, there is an input layer, which is basically when we see some data or maybe see some information or the image or video, it comes as a reflected signals of the light and finally it reaches. Inside the brain, we have this sort of complicated layers of multiple layers, and there is one input layer which is basically fed with the information of the features, and then finally the processing is done, and at the output layer we get some sort of output. So this is just an example how we identify the handwritten digits. If we write 7, 8, and 4, and as a human we quickly identify. So what exactly happens when we see something? Whatever way a person has written 7, 7 can be written maybe 10 million way, different way. But as a human, we are able to understand. So we do not remember the image of the 7, but we remember the information or the ages or the stroke, how 7 is written. We try to predict as much as possible close to the answer. And that is why we are able to do that. Just to take another example, that in our life, when we were in nursery or KG or maybe in the first standard, we learned about and there was a Z for zebra. So maybe many of us might not have seen the real zebra still now in our life. But whenever, if it appears in front of us, we are able to quickly identify that this is zebra. Why? Because there is a information which has been stored in terms of ages and the strokes or maybe the shape and size of the objects, which the basically the visual cortex has transformed, and finally it reaches to the brain, and then brain does the analysis for all these things. So this is very interesting stuff to know that how these human brain work as well as how the network works. Both works in a similar way. If you look at this example, there is a lady in this particular photograph, and look at the top, look at the bottom layer. This is called the visible layer or the input pixels. When we see any photograph or when we see any image, it is made up of number of pixels. For example, there is an image which is of 32 by 32 pixels. So there are 32 pixels in a row and 32 pixels in a column. Each pixel is lightened up because of the property of the material. Whenever we see some light, it actually reflects the color basically. And when we record something in our brain or when we see something, it actually creates a shape of that also. So if you look at this visible layer as an input pixel, the next level is basically to find out the first hidden layer. That is basically the age identification, because in any image, we can set some boundaries, and this is nothing but a kind of an age of a particular object. Then the second hidden layer identifies the corners and contours into that. There may be variation, and then finally it identifies the parts of the object. And later on, the human intelligence identifies the object identity, whether it is a car or a or an animal, or maybe again inside the animal, maybe there are different types of animals. If you have a data of number of different animals, we are able to identify that this is cow, this is buffalo, this is dog, etc. So that is human intelligence, and similar things happens inside the computer systems when we use machine learning for that. Okay, there are two different ways of learning in terms of machine learning, that how a computer learns. Even similarly, the human has also learned like that only, which is known as the supervised learning, the unsupervised learning. Everybody talks about 3 o'clock. Everybody talks about supervised learning and unsupervised learning in the beginning of any of the AI related lectures. So let me tell you, when you provide the data with information or the labels to the computer system, it is basically the supervised learning. So let's say let us take an example that I have the data of dog, cat, or maybe I have the data of different fruits and vegetables. I take pictures of all these different types of dogs and cats, or maybe different vegetables or the fruits. If I store them into my computer, I will provide them the labels like that. Okay, this is a photograph of apple, this is of banana, this is again of apple of different type, but this is again an apple. Then we provide all these labeled data to the computer system or the model of the artificial machine learning. We actually use supervised learning. But in case of unsupervised learning, it happens that the machine model tries to understand at its own. It tries to identify the similarity or the pattern or clusters from the data and try to segregate them, or maybe to cluster them, that okay, this is type 1 data, type 2 data, type 3 data, etc. So similar thing has happened to us when we were kids. Like our family members, or like say papa or mummy, used to tell us that this is mama, this is dada, this is nani, etc. So we were basically provided with the labels, and it was something like supervised learning. And for the first time, if somebody gives you an information, that is basically a supervised learning. But over a period of time, we also learn in terms of an unsupervised way. Say if I travel to Nagpur and if I don't know for the first time, I will try to find the way how to reach to HRDC Nagpur office. So that is something which is unsupervised learning, where I don't know anything, but I will try to find out my results. Another example, that if a foreigner comes to vegetable market in India, maybe there are lots of vegetable available which may not be available in his or her country. And if we ask them to buy something, he may be buying all the vegetables together, different shape and size. But now at the home, if we ask the person that you just identify these particular vegetables, so he may not be knowing the names of this vegetable, but he will be definitely able to classify them by just looking at the shape, size, weight, and everything. So you will be able to segregate them in different clusters, and finally you can give some name like X, Y, Z, A, B, C, etc. So that is something what the machine learning model does in terms of unsupervised learning. So when the training data is basically a labeled data, it is called supervised learning. Like we have different photographs of dogs and cats in a different background, color, shape, size, orientation. All these things are possible in case of supervised learning, where you can have different data, but we need to provide the label. So classification model will finally give you the output for the that type of the data what we have provided. In case of unsupervised learning, the machine learns from an unlabeled data set. Let me add here somewhat about the machine learning process. The simple process is something like that I want to create an AI system, or maybe I want to create a machine learning model which actually acts automatically to do some predictions or to identify something based on the input data which has been provided. So in case of AI field, we usually don't call database, we call data sets. How they're different? Because in case of database, we have almost structured data in some sort of specific formats, or maybe using some rules and regulation, we structure them. Take an example of an Excel sheet which has a kind of a structured data. Most of the things are structured. So that is basically the database. But when we talk about data set for AI, it actually contains different types of data. Maybe it is a video data, maybe it is a audio data, it may be a textual data, it may be a kind of a language data for natural language processing kind of an application. So when you have different sort of data, and again, it cannot be stored in a single format. You can keep all the data into your Excel sheet, or maybe in SQL database, or maybe in case of an Access file, or maybe a notepad. or maybe a kind of a normal CSV file, then it is a kind of a database. But when we talk about images, when we talk about different audio sounds, maybe a kind of a video, these are all in a different formats, but you cannot put them into a kind of a file or an Excel sheet. That is why we call it as a data set. So we need data sets for machine learning applications. Again, the fundamental principle of any machine learning is that you should have enough amount of data to perform your task. So what does that mean exactly? Until and unless you do not have enough data, you will not be able to train your model effectively, or maybe it may not work properly if the data is not sufficient. Let me give you an example that I want to create a mobile app which is having a AI capability, or maybe a machine learning model inside running inside a mobile app. Whenever I start the mobile app, it will start the camera. And if I keep the camera in front of any of the person, the application will be able to identify the gesture of that person. Gesture, maybe the person is smiling, maybe the person is disgusted, or maybe angry, or maybe excited, or sad, whatever gesture we want to find out from that mobile app. And it will also show you the accuracy of the gesture, whether the person is 90% happy, or maybe 90% angry, 50% disgusted, normal, whatever we want to find out, we can find out. So how to do that? So we need some labeled data because we want to do supervised learning. And for that labeled data, we need to capture those different gestures from different people. Okay, now if I'm doing this project into my college, then I will be able to contact the students, maybe the faculty members, to capture the data. Now the thing is, if I take only 20 photographs for a kind of a happy gesture, 20 photographs for an angry gesture, maybe 20 for a disgusted gesture, then I can use this particular data and I can train the model. But what will happen that it does not contain sufficient information from these 20 gestures only. Maybe there are similarities among their smiles, there are similarities among their angriness, or maybe you cannot say that it will work for everyone. But now if I collect data, say for example, 1000 photographs of gesture having smile from Gujarat, 1000 from Punjab, 1000 from Tamil Nadu, etc., I will have huge amount of data. I have diversity in my data, and because of this diversity in the data, the model which will get trained after the processing will have more accuracy, will be able to predict more accurately. Again, going beyond that, uh, if you open the website of University of Carnegie Mellon University, they have these sort of data sets already available because they have done some sort of research work on gesture identification. So they have collected huge amount of data. If you download that data set, it may be something around 2 GB of data. And you will find that there are gestures of smile for different 50%. And there are around 500 photographs for a single gesture. If you download that data set and train your model and create an application here, again you will be able to see that it is not perfect. Gesture is around sometimes 80% or maybe sometimes 90%, but it is not as good as what it should be. Why this happens? Because whenever the university, Carnegie Mellon University actually created the data sets, there were mostly Europeans and Americans into those data. There were no Africans, there were no Asians into those data. So again, only the number or the huge amount of data is not important. The data should have a diversity also. Because until and unless you don't have the diversity, it's not going to work. Something about diversity. It is something about the amount of data. So I say that more the data you have, more the truth you have in terms of your machine learning model. So this is one of the important things which we need to keep in mind, because in most of the research which happens in India, people do not focus on collecting the data. They directly start jumping on to making the applications. But the core research which the companies are doing like Google and Amazon are specifically working for collecting the data first. Maybe they spend 1 or 2 years for collecting the data. They try to see that there should be data from every part, from every place, from everyone, and finally it has to be a strong and reliable model. Now, what sort of different machine learning outputs we get when we use different types of machine learning algorithms? So we have kind of a regression, classification, clustering problem, sequence prediction. And all of this we have experienced in our day-to-day life, that if you want to predict the continuous value, we use regression basically. When you have numeric data or a kind of a time series data, we definitely go for regression and we may predict something. When we want to identify or in terms of classifying some objects, or maybe from a video or maybe from an image, if you want to identify or the class of that particular object, we go for classification. It is all about predicting a class or a label like cat and dog. Clustering is something related to number of applications we are using so far in terms of Amazon shopping application. Then we have Spotify, we have Amazon Music. All these are basically the examples of clustering paradigms. So what does that actually? When you are searching on Amazon and if you are looking at some of the product which you are interested, maybe I'm interested in shoes and I want to buy a sport shoes. So initially when I search simply shoes, the Amazon does not know about my choice. It only understands that I'm interested in shoes, but I'm still not interested in the leather shoes, but I'm interested in sport shoes. So till that time, Amazon is not knowing about your choice. But once you click on any of the sport shoes, it understands that okay, your choice or your inclination is towards the sports related shoes. So it will start showing me the images of the sports shoes later on. And again, if I look at some of the information related to the price or the brand, it will try to again recommend me for the data related to my interest. So this is something about kind of a clustering where we do content filtering. Similar thing happens when we go for Amazon Music or maybe the Spotify. If I'm interested in listening the songs of 80s only and maybe the songs of Jagjit Singh or maybe Kishore Kumar, and if I start listening them, it will try to suggest me the songs related to that. So it understands your choice and test, and basically based on that content filtering, it provides you lots of information in which you may be interested. Then there is a kind of a different application where we do sequence prediction, where we want to predict what could be the next sentence or the word. This is also a very popular application in our Gmail, which is inbuilt right now. If somebody has sent an email and if you start replying the email, it will start predicting the next word, or immediately it will suggest you the sentence formation also, that you can reply like this, or maybe if you want to type, this is going to be the best line. So these are some of the applications of machine learning outputs where we use sequence prediction. So if you talk about use cases of this one, image classification or the object detection or object identification, this is a kind of an example where it identifies any angle from any level. Let me give you an example that in 2017, we had created a project for identification of the weights of the potatoes just by using your mobile phone camera. So as a human, we are so intelligent. And if you are a regular visitor to the vegetable market, because I go for vegetable purchase every day because that is on my job basically. So when I go to the market over a period of 20 years, I am able to identify that okay, this potato may be containing weight of 400 grams, maybe 200 grams, or maybe 50 grams. And if the potato is very big, it means that it may be 500 grams. So maybe 2-3 potatoes will suffice for 1 kg. And if you are having small potatoes, you need 6 to 7 different potatoes. That is human intelligence. But I wanted to make an app by which I will be able to identify that if I target my camera on a single potato, it should show me the weight of that potato. How it is possible? It is very easy and very simple to understand using machine learning models. That we went to the market to a wholesaler of potatoes and we asked them that how many different types of potatoes you have in terms of weights. So he told us that okay, we have the biggest one of 500 grams usually available in the market. Then there is another one is around 400, and then 200 grams, 250 grams, 100 grams, 150 grams, or very small potatoes having 70 grams or 50 grams. So we asked to give us samples of those different weights. We collected 100 potatoes of 500 grams and we started taking pictures of those potatoes from different angles. Like you see in this image is basically the person is moving his camera around the table. So we took those photographs. For a single potato, we took around 40 images. So from different angles, and there were similar type of 100 potatoes, say for example. So we collected huge amount of data of those potatoes and we labeled them in a folder of the computer, that this folder contains the 500 gram potatoes images. This folder contains 400 gram of potatoes images and so on. And then we started training those data and we created a mobile app. We deployed the model into a mobile app, and it was so interesting to see that it was successfully able to identify that weight of the potato. Even though you move your camera close to the potato or if you go far the potato, it was able to identify, because while creating the images or capturing the images, we had taken the photographs like that only. If you take all the potato photographs having a centimeter distance, then definitely it's not going to work from a larger distance or a longer distance. So diversity in data, as I talked just a few minutes ago, it is very important that whenever you see any of the information or the data, you should have more diversity in collecting those information. So this is interesting to see that how we and how the computer understands and how we actually identify the information from the available unknown data. That is what the concept of machine learning. So object recognition is also very important. We identify various objects. Recently, we guided our student for dissertation in terms of identification of government vehicles, not only from the number plates, but we were actually able to identify the government vehicles from various different features available on the vehicle of the government. Maybe there's a blinking lights, or maybe there is a different kind of a wireless set, or maybe there is a loudspeaker, maybe there is a kind of some sort of accessory on government vehicle. We were able to identify those things from and we were able to successfully run a live video stream using Arduino Nano and a video camera, and we were able to identify how many government vehicles are moving into a city and going out, and we were able to do video data analytics for those things. So that is something about object identification. There are lots of vehicles, but you want to identify only the government vehicle out of that. That is possible. Then there is a speech and sound detection. This is again an interesting area where we can guide our student for speech and sound related data. I would like to share one of the biggest achievement we had last year. We were the global hackathon winner for a contest organized for machine learning for ICT systems. It was organized by International Telecommunication Union. And we had submitted a very interesting and innovative idea for identification of the mosquito species by their wing beat sounds. What does that mean actually? When you see a mosquito, human is that much intelligent in terms of identifying a mosquito just by looking at the mosquito that it's a Anopheles one, or maybe the Culex or an Aedes aegypti. So these are some of the things we wanted to identify by their wing beats. So if the mosquito is different, definitely the wing beat sound is going to be different. So we try to learn something about the mosquito types and everything. We found that there are lots of species in the world, but the most deadliest one are the Anopheles, Culex, and Aedes aegypti. These are the three species of the mosquito. And we even referred the WHO data and found that the mosquito is still the deadliest animal in the world, and the second rank is of the human. So even after discovery of malaria 100 years ago by Dr. Ronald Rose, we are still fighting with the mosquito-related vector-borne diseases. And our aim was to identify. No doubt we have different ways of identifying the mosquitoes in the laboratory. Just collect the larvae and put it them under the microscope, and we'll be able to see that okay, that this is a type, the species of that particular larva is of this type. But we want to use some sort of machine learning into that. So we found that there is a very good data set available for mosquito wing beats. Like the data set was only containing मच्छर की जो गुनगुनाहट होती है ना, वही था उसमें. I mean to say, like there were only sounds of mosquitoes, but they were categorized in terms of label data, that this particular 2 GB of data contains the sound of wing beats of maybe Anopheles or Culex or Aedes aegypti. We downloaded all of them. It is only a 10 second of samples inside that in the WAV file format. We downloaded them. We created a model of classification. But what we need to do when we have a sound sort of data or an audio data, we actually transform all these data into images. So there is a very good concept, and those who are aware of transforming the data into a spectrogram, when we have an audio data, we can transform all these data into a spectrogram. So when we convert all these images into, all these audio files into images, and then it becomes very easy for a machine learning engineer to create a kind of a classification problem. We do kind of an image or a deep learning concept we use for that. So we created a model. Then we transferred the model, actually transformed the model into a very small model, because when we created a model, it was something around 118 KB, but when we, sorry, 100, not 100, it was 150 MB for the computers, because we use 14 GB of data for total mosquito sounds, and we got a model of 150 MB. But we wanted to use it on a microcontroller, because on Arduino, if you want to implement this particular concept of tiny machine learning, we had to transform that. So we used TensorFlow Lite library, and finally we transformed that model for a very smaller of, I need to say around 18 KB of the file was of that model size. We deployed that model on an Arduino Nano. We connected a display. And finally, when there is a mosquito flying in the room, it was perfectly able to identify the type. So if you have a mosquito in your home, it will show you that Anopheles is flying, or maybe a Aedes aegypti is flying, or a Cule is flying, just by identifying their wing bits and the type of the mosquitoes. So now you can imagine that if you implement the same model into your Amazon Alexa, or create a skill for the Amazon Alexa, it will be able to tell you that, hey, you have an Anopheles, which is a dangerous mosquito flying inside your home. So this is one of the things how we can use different sort of innovative ideas to implement into machine learning using speech and sound detection. Then very interesting part is natural language processing. NLP is one of the very interesting area. Most of the people know that, like Twitter and all of them are highly used for NLP, and even your WhatsApp chat is also very much used by natural language processing concepts. Maybe we are chatting in our own language, but we type in English. For WhatsApp, it becomes very difficult to understand what you are communicating, because it does not understand in a normal way. Like if I'm typing something, मैं आ रहा हूँ, so I will type MEAARAHU. So that becomes very difficult for an NLP to understand, because it's not a normal English. It is basically a Hindi language, but we have written into an English. So even these WhatsApp models are so powerful that even they are able to understand the communication happening between two different users. No doubt there is a privacy, there are encrypted messages, but still when you download a whole data of your group conversations, you will be able to do lots of data analysis out of that. Another area in terms of natural language processing is all about utilizing the human power to understand. If any one of you is aware of a new platform known as a Hugging Face, HUGGING Hugging Face. Hugging Face is a platform. They do lots of research and innovation in terms of machine learning area. And recently they have come up with a very good model which is known as a transformer. And this transformer has one of the very good interesting application in terms of doing making a summarizer. Say for example, I have a book, maybe a novel, and I'm reading the book every day, maybe for 2-3 pages or 10 pages every day. And maybe after 1 month, I will finish the book completely. So if someone asks me that, hey, what was there inside that book? Or maybe what you can summarize. So definitely I have read that book and I will be able to summarize that. If you are given a single page of the book, and if I ask you what is written in that book, you can also summarize the single page. And as a whole, you can summarize the complete. So this particular transformer model has created a very interesting area of application in terms of summarizer. You provide text to that particular model, it will summarize everything for you. Maybe it is a 100 words, 50 words, 75 words. You need to provide that information to that, and it will give you the summary. Even 400 pages of book can be summarized in 50 words, and that is almost perfect or close to the perfect, which a human cannot do sometimes. Another area is prediction and translation. That is also widely popular today. So I have talked lots of things about model, but let me give you a clear insight about what exactly is model. A machine learning model can be mathematical representation of real world process. And to generate a machine learning model, you will need to provide a training data to a machine learning algorithm to learn from. So as I talked about data set is basically the food for the model. Once we provide that particular data and we sort of machine learning algorithm using the mathematical concepts, finally we get some output, and that is nothing but our model. Another scenario is basically a training versus inference. Inference is also a very popular word you may come across many a times when you are talking about or learning about AI or ML. So training is basically the process of the machine learning algorithm builds a model of the system based on the data we provide. But inference is basically utilizing the same trained model for some sort of application. So the process of running data through the model to make predictions. Like most of the popular models which have been created or innovated, I should say, from different universities, different companies, like MXNet and ImageNet, and then ResNet or maybe VGG16, VGG Mobile, etc. These are very popular architectures and models for machine learning. Maybe Inception, which is developed by Google, it's a very huge model which contains lots of information. So if you want to create some sort of application, there is no need to collect the data, there is no need to train the model, because it is not possible for us to train such a big model having such a huge amount of data. Even Google took 3 months to train that model, having a very super power computing infrastructure. So we have our normal computers. For even a kind of a 10 or 20 GB of data, your computer may take 1 week of time to train this sort of data. And that is why it is not possible every time for a normal person to train the data having huge amount of data set. So sometimes these companies or maybe the universities or some research papers, they have created this sort of bigger model, maybe having lots of energy involved into them for developing them. We can use directly them for our applications, and that is nothing. That's what we call it as. There is no need to do it from the scratch, from the beginning. Now, similarly, like in case of machine learning, the very popular platform today is TensorFlow. So many a times you come across this particular word, it is better to know the concept of what exactly is tensor. So deep learning models accept input and generate output in the form of tensors when we are talking about the TensorFlow. A tensor is essentially a list that contains either numbers or other tensors. It is something about, if we talk about the features of the data, you can think of similar to an array like scalar, then we have vector or matrix and then tensors. So it has multiple dimensions. Like as in the figure, scalar is a single dimensional, vector is matrix is more dimension, and tensor is, you can say, higher dimensional matrix, any shape with more than 2 dimensions. So this is something about when we are interested utilizing huge amount of data, having lots of features. Say for example, I want to create a model which predicts the price of a particular housing property in a particular city. When we are talking about the price prediction, it has lots of feature involved into that where the area is, what the city is, when the house was constructed, where it is located in a particular area, how much built up area is there, how much open space is there, how old it is, how much renovation is required, maybe what are the facilities inside the house. There are a number of aspects which decides the price of a particular property, and that is why when we talk about features of the data, we need to go for tensors. Then again, it comes a concept of CPU, GPU, and TPU, which is known as tensor processing unit. We are aware of CPU and GPU, but TPU is one of the concept by Google, which has actually given a rise to TensorFlow processing. And they have also created with some of the sticks, USB sticks are available, which are TPU sticks. So just by comparing, what I want to convey here is that GPU is more powerful than CPU, and even TPU is also powerful than the CPU. So these are basically the concepts of CPU, GPU, and TPU. Now, what are the different challenges for machine learning application when we are talking about exclusively for embedded systems? So the first thing is that overbearing prerequisite system knowledge for setting up the environment. Many a times it happens that person having a domain expertise, but when it comes to machine learning or when it comes to create and deploy an application on any of the hardware or maybe on the computers, there of some system knowledge is required for machine learning. It is difficult to know exactly how much data is required to train an effective model because there is no rule like that. More the data you have, more the truth you have, more powerful model you have. But there is no rule. Maybe sometimes you can train the data with say 100 images or 100 audio files or maybe 100 input data. Sometimes if you have 2 GB of data, that is also not sufficient. So there is no guarantee that you will be able to achieve good enough accuracy for the problem you are trying to solve. So these are some of the challenges right now. And the third one, which I talked about, there is no guarantee that you will be able to achieve good enough accuracy when you are trying to solve. This is one of the area where most of the faculty members from computer and IT who are interested in machine learning target their PhD problems. Somebody has created a model which is a kind of a fundamental innovative model or maybe a kind of an algorithm. Now the researcher who is interested in PhD will try to take that particular as a base and will try to implement or enhance the efficiency of the model, or will try to come up with a new idea, new model, new output. That can be one of people are working in terms of PhD problems also. So what can be the workflow for any of the machine learning project? First of all, you need to decide the goal. to do. As I told you that we wanted to find out the species of the mosquitoes. The goal was very clear that that is what we need from our machine learning concept or the project. So what do we need? Initially, we need the data first. So collect the data sets. There are a number of ways by which you can collect the data. There are some domain specific data which may not be available freely. There are huge amount of data which are available right on very popular websites like kaggle.com, kaggle.com, kaggle.com. So Kaggle provides you different data. You need to simply search. Say, for example, I want data for, say, human activity. I want to create a wristwatch which actually identifies my pattern of walking, maybe the my speed of the walking. Even using wristwatch, you can identify your speed also. Without GPS, you can find out that how you are moving, how fast you are moving, how fast your accelerometer is generating the data because of your motion and movement. So these are some of the data sets available on the kaggle.com. It also contains data for medical areas like cancer detection and the lung images or the images for various fractures. So based on your goal, you can go to the kaggle.com and you can download the data. They are available in huge amount. I mean to say 2 GB, 4 GB, 10 GB of data available for any of the project you are interested. If it is not there, you need to create your own, and that is very important. But whenever you are creating the data, see that it is not biased. I mean to say there should be a variety, there should be a diversity into that. So collect the data set, design a model architecture. That is interesting thing that you need to know what sort of problems you are trying to solve. As we talked about the clustering, classification, and all these things, regression, clustering, sequence prediction. So you should know that, okay, I'm going to solve this sort of problem. This is going to be the best solution for my model architecture. Okay, next part would be to train the model. Depending upon the quantum of the data you have, depending upon the type of the data you have, the model you have to design and define, and finally you need a platform to train them. If you take Raspberry Pi or maybe an Arduino, nothing is going to happen because it does not have any computing power. The data cannot be trained on Raspberry Pi. You need to go to your computer, train the data over there, get the model output, and finally deploy that model onto a hardware. If your computer even is not sufficient to train the model, you need to go to Google Colab, which is a collaborative space for Google Cloud storage data, and most of the machine learning libraries are deployed over there. You need not have to do any setup into your computer. Simply go over there, log in into your Gmail account, or directly open website like collab.google.com. It will take you to the Google Colab directory. You need to log in using your Gmail ID, and finally you will be able to upload the data, write the code over there. It gets trained onto Google Cloud server only. The only thing is that it never stores your data. Once you are logged off, it will flush out your data, whatever data you have uploaded. But you will be able to see your code. You will be able to download your model. It retains over there. The only thing is that it does not allow us to store the huge amount of data. So for a temporary time, until and unless you are logged in, everything is available. Once you logged out, everything will be flushed out. So that is one place where you can do all these activities. Then convert the model, because if you are targeting the embedded systems or the hardware, electronic hardware, you need to definitely convert the model to a smaller size, because the flash memory of the microcontroller is not able to run a 150 MB of model or maybe 200 MB of model. So we need to convert them using some sort of tools which are available. Most of the libraries are available for various architectures and technologies by which you can use their commands to convert them. And finally, what we will be able to do that once we load the model or when we deploy the model on a hardware, run the inference. It means that now we are not going to train anything on the microcontroller. It is already there. You have a logic or maybe a kind of an output which is there available on the Arduino or the microcontroller itself. Now you provide an unknown data, it will give you the output for that based on the training you have. If your model is accurately trained in terms of more than 90% of the accuracy, definitely it is going to work well. And if it is not trained well, maybe the model has a 50% of accuracy. That means it is not at all trained. Either it is going to predict like this or that. It means that 50% accuracy is basically a wastage of time, and it is not called a kind of a model which has been trained. It is a kind of a simple yes or no kind of a thing, optional thing. So better is to have an accuracy more than 75 or 80%. No company in the world today even claims that they are able to train their model up to 100 100% of accuracy. So that is even not possible. As a human also, we are not 100% accurate in any task. Even whatever task we do every day, we cannot say that we have accuracy of 100%, but it is always 99.99% accuracy. Then you can evaluate and troubleshoot the model. If it is not perfectly working, you can retrain them or maybe try to change the data. Sometimes there are some outliers data available. If you remove those outliers, definitely you are going to have a better model output. Just to give an example, I want to create an application by which I want to identify or maybe I want to predict a relation kind of a thing. Say I'm collecting the data of final year students who are preparing for GRE or GMAT, and there is a data of those students for their performance in the final year. There is no relation between them, that whether the student is preparing for GRE GMAT or whether the student is performing for the final exams of the subjects in which he is enrolled. But I want to see that is there any specific relation, is there any model which I can brought out. So maybe I'm collecting the data and I want to find out some relation. Maybe I'm able to find out that those students who are performing well in the GMAT are getting very good marks in their final year examination. Maybe because of some sort of skills they have developed or something like that. But while collecting the data, if my data for 2 to 3 students is entered wrong into the data set, say for example, GMAT result is around maximum marks is 500, but somebody has entered 4,000 instead of 400, or maybe sometimes instead of 100 it is minus 100. So now I have lots of change in my data. I mean to say there are outliers in the data and they are going to change my model concept fully. So I need to say that if I can go and evaluate and troubleshoot my model again by looking at the data. So when we collect the data, it is very important that we need to go for data cleaning, data pre-processing, data sometimes filling also, because many a times it happens that some of the rows are blank because of some or another reason. If it is a sensor data, maybe many a times the sensor has stopped working. You will have empty rows where the data is not stored. Maybe there are null values or maybe zero values. So definitely it is going to change your model accuracy. So this is the workflow for the machine learning project where we need to decide the goal, collect the data set, design a model architecture, train the model, convert the model, run it on the device, and finally evaluate and troubleshoot. This is what most of the companies are doing. Google Photos has provided us the free facility that you can upload your photographs onto the Google Photos. Why? Because they are already having the trained models running over there, and as and when you upload the data onto the Google Photos, the model becomes more powerful and more accurate because it again understands. So nowadays, if you look at the Google Photos of your Gmail account, it will be able to search you the photographs using sunset or maybe boats or maybe kind of greenery or maybe gardens, etc. So all these are possible. Why? Because they have used your data. They have used number of data from the different users in the world that do not look at the photographs, but their models actually use this photograph to again improve more and more, and that is why it is able to predict the information very quickly. So now I will go through some of the this is one of the interesting thing available today by Jetson Nano by NVIDIA company. So those faculties who are from IT, computer and electronics background, NVIDIA has a very good facility to provide you the hardware grant. You just go to their website and just search for Jetson Nano 2 GB hardware grant. You apply with your details and they will definitely be happy to send you a few kits, maybe 5 or 10 kits by which you will be able to create your own machine learning application. It comes with camera and number of things all together. So this is one of the board which you can use. Arduino Nano is also a good board by which you can start. Raspberry Pi, most of the people are already having, so and there is no grant program by the Raspberry Pi, but you can also run your machine learning applications on the Raspberry Pi. Then these are some of the ready-made kits available by Google. In Amazon, it is available. It is good for your even engineering students or science students or electronic students. Vision kit and voice kit. It comes with a Raspberry Pi by default inbuilt into that. In the box, it comes with a it comes with a loudspeaker and microphone. So you can create systems like Amazon Alexa or Google Home at your home. Normally we call OK Google for awakening the Google Assistant. If I want to create my own assistant for my college, say for example, we want to create an assistant for HRDC Nagpur. So we may call the assistant, hello HRDC. And finally, what the information you have used to train that particular HRDC help assistant can answer the questions based on your inputs. So you need to collect the data set like that, and you can use this particular device. It is not even much clear item. Anyone can start with the available resources, and there is very good documentation available for the vision kit as well as the voice kit. If you want to make a application for a camera, you can go for the vision kit. If you want to make an application for the speech related AI ML, you can go for the voice kit. This is another board by Google itself. It is known as a Google Coral board. The price is a little bit higher as compared to Raspberry Pi. It is something around 8 to 9,000, but it is more powerful than Raspberry Pi. I should say it is having a TPU inbuilt into that, and there is no need to no need to have a training outside the board. So it is better to use as compared to Raspberry Pi. You can go for the Google Coral board. Then we have. This is one by SparkFun. If you open the SparkFun website, you will be able to see that there are boards available for most of the TensorFlow applications or tiny machine learning application. Even you can create and deploy quickly some of the interesting speech related or maybe the camera related applications for machine learning in terms of identifying the voice or identifying the keyword, etc. This one is by ST Microelectronics. It comes with a display also. So this is again a very low power and low cost device which supports machine learning. This is by again Adafruit. Adafruit is a very popular company which actually sells number of boards, and this is one of the Edge Bridge and TensorFlow like microcontroller kit comes with display and number of ready-made available code which are supported by the board itself. This is by Braincraft, which you can put it onto a Raspberry Pi and you can use that for your machine learning applications. Now we are going to discuss about the board in which we are interested, and even you can buy this board in India. It's available. It is costing something around 3,800. But the beauty of this board is that there is no need to connect any sensor out of the board. Most of the sensors are already available on the board itself, and you can use for creating various ML applications. The first very interesting thing, and everybody is interested in terms of movement related stuff. The first sensor I would like to talk about is the accelerometer. It is 9-axis in 9-axis accelerometer. So, which is very much useful for creating wearable applications for wearable devices. Nowadays, we use the Samsung Watch or maybe Apple Watch. It has a accelerometer, 9-axis accelerometer, which actually identifies how many steps you have walked, if you are running, if you are riding, if you are sleeping. It identifies the sleeping pattern and number of things altogether. That is just because of this particular accelerometer sensor. Another sensor is humidity and temperature. That is also very important to use and make ML applications for predicting number of things altogether for environment related applications. Barometric sensor is for weather station. Microphone is also inbuilt. If you look at the chip, the RF chip which is shown on the board, very close to that there is a microphone, and the microphone is also very sensitive. You can make applications like Google, Alexa, Google Home or Alexa. Gesture, proximity, light and color sensors are also on board. So if I take my hand close to the board, it identifies the proximity, whether somebody is close to the board or not, like our mobile phone itself, which has a proximity sensor. Gesture sensor is also very important in terms of finding out whether you are moving your hand from left to right to left, close or far, or up and down. These are some of the things which the sensor can identify. Even it can identify the colors or the light intensity also. So if I want to make an application which identifies the fruit, but there is no camera, is it possible? Yes, it is possible, because we know when we have different fruits, they have different specific colors. Maybe there are some similar colors also, but at least we can identify whether we want to identify apple and banana. They both have different colors. So collect the data of their colors only using these sensors. create a data set, create a model, deploy it, and finally, without camera, it will be able to identify whether it is a banana or an apple. But definitely, when you bring any other color, it will be wrong. Now, these are some of the features for the memory size of this board. It is good in terms of the previous board. You can connect the camera with this board. So something like that, if you want to create a voice-based application, if you speak yes or no, it identifies. You need to simply deploy this. These are ready-made example available on the TensorFlow website, which you can use for having a quick start on this board. If you use TensorFlow for your mobile application, there are again various models available which you can directly deploy into a mobile phone application, specifically Android application, to classify and detection of the objects. Okay, so now I talked about sensors. The first one is orange one, that is color, brightness, proximity, and gesture sensor on the board. The blue one is the digital microphone. The yellow one is motion, vibration, and orientation sensor. You can even make applications for earthquake detection, because you know that the seismograph basically understands the vibrations of the earth. And similarly, the accelerometer is also used as a seismographic phone, or seismophone they call it. The similar thing can be used for identification of the earthquake. Even you can predict the things based on the previous data. And the processor on the board is basically ARM Cortex processor, and that is why you can run machine learning applications. The normal Arduino Nano cannot work for implementing these ML applications. Okay, now how to start? The very important thing for having, once you have bought the board to run directly, there are some specific procedure we need to follow. Most of you might have used Arduino IDE, but when you go to the boards manager, you see all the list of all the boards available. But even though your Arduino IDE is updated, or maybe you have a fresh piece of Arduino Nano 33, if you connect with your computer, it's not going to show that board. You need to find that board by going to the board manager. Just search for Nano 33 BLE, and you will be able to see that is a library for that particular board. You need to install that, which is known as an Arduino Embed OS Nano boards. Once it is there, you will be able to see the board if you connect the board with your USB inside the computer, and you will be able to see the board like board Arduino Nano 33 BLE, and it is available. So this is the first step. Don't forget, otherwise you will never be able to find out the board itself. Second thing is to identify what are the different sensors and the libraries which are required, because whenever we want to use of a particular hardware or a sensor, there are specific libraries and there are specific functions to use that particular sensor. So if you want to use your accelerometer, if you want to use your microphone, gesture, pressure, digital proximity, ambient light, red, green, blue, RGB, and gesture sensors, relative humidity and temperature, there are all libraries available. You need to simply search using their name. Like say, for example, here the fonts are very small, but it shows that the sensor is AP05966. So you need to install the library for that. It is available. And now, very interesting platform which I'm going to discuss, that many a times it happens that as a beginner, you don't know much and there are lots of things to learn. But you are crazy behind making any ML application and you want to create some application. So what will you do? The best thing is to go to the Age Impulse platform. Age Impulse is a company which has created a very good platform for an expert or maybe an intermediate or maybe a beginner. You can log in using your account into the Age Impulse website and start creating ML applications. Even though you do not have accessories or the hardware or the sensors, they provide you that using your phone, you can collect the data. Maybe I want to collect the data for images. Maybe I want to collect data for audio file. Maybe I want to collect data for accelerometer. All these sensors are inbuilt inside the phone. You can use your mobile phone, and there is no need to even connect the phone with your computer. It connects automatically wirelessly in terms of the cloud network. And here you create and generate your data that goes to the Age Impulse website. Then Age Impulse is a platform which actually gives you a hint. I mean to say, if I have audio data, if I have image data, if I have kind of a video data, it will suggest me different architectures and model as a beginner that, okay, you don't know, go for this sort of algorithm. It will be helpful to train your model. And finally, it trains on the cloud itself and it gives you an output. Now it gives you an option that whether you want to deploy it into a mobile application, whether you want to deploy it on a hardware, whether it is Raspberry Pi, whether it is Jetson Nano, whether it is Arduino Nano, you can download and deploy that directly. Even for Arduino, it creates firmware also. There is no need to sometimes load the program, but it will completely change the firmware of the Arduino. And finally, that Arduino will be a kind of a specific machine learning board for your application which you have created. So how is the procedure for Edge Impulse? That similar procedure what we had seen so far in the past few slides, that create an impulse or collect the data, train the model, and finally deploy. These are some of the screenshots of the Arduino, Edge Impulse platform, that when you start the project, it shows you something like that. Select the project. If there is no project, you can create your own. A new project is created using some name. Later on, it asks you that which type of data you have, whether you have an accelerometer data, whether you have audio data, whether you have images or something else. Something else means you may be having numerical data, you may be having genetic data, you may be having a kind of, I should say, numbers, NLP related data, anything else. So initially it gives you an option. Maybe we are interested in accelerometer data. We can click on that and finally a different sort of environment or the workspace for you. And there are different options available. You need to follow them one by one. And similarly, it will show you that how to collect the data, whether you have all the data collected in a pen drive, you want to simply upload them, you want to use your mobile phone to collect the data, or maybe you have different board which is connected with the Edge Impulse platform, or data from any other forwarder. Maybe there are some forwarding device, like maybe my Jetson Nano is connected, or maybe my temperature sensor is connected at my lab and I'm working here. So maybe there are some forwarders who are actually forwarding the data to this particular Edge Impulse platform, or maybe I want to upload the data, or maybe integrate with the cloud. I might have my lots of 20 GB of data on my cloud. This gives you an option to take your data from anywhere. Another thing is you need to install some of the dependency for the Edge Impulse command line interface setup. This guide is available on the website itself, but if you will not follow this process, you will never be able to run any application or deploy any machine learning model onto the Arduino itself. So these are some of the specific things you need to keep in mind while starting your first project. So what do we need to install? Install Python 3, Node.js version 14 or higher. If it is not there, it will install. These are all automatic process. Even if you don't know anything about Node.js, it is fine. It will get installed. You need to prepare your PC to run the command line interface for Arduino. And from the Arduino's website, you can find out the CLI details. You need to install the Arduino CLI, and finally the Python and the JavaScript, Node.js. These are some of the few specific requirements, and then start collecting the data. You can collect the data from web browser also. You can collect the data from your mobile phone also by connecting them remotely by pen drive, all the options. So whatever options you have, all are available. Okay. So now I need to see. Is this slide is fully visible or?
Yes, sir, it is visible.
Okay, now let me show you a simple example where I have connected an accelerometer, or maybe the onboard accelerometer with the Arduino, and I'm looking at some of the waveforms of these data. So these are some of the data of accelerometer. Whenever I'm moving my Arduino board, I'm generating some data and I want to create some data. So On the serial monitor, I will be able to see the data like acceleration in X direction, acceleration in Y direction, acceleration in Z direction. Similarly, the GX, GY, and GZ, that is basically the gyroscope data. So whenever we are generating these data, they are available in numeric formats. So for a specific gesture, if I am, say for example, if I rub something, so my gesture is something similar to like this. But even if I do like this, it would be different. Even if I do like this, it would be different. So I need to see that which sort of gesture data I want to generate. Once I'm able to use this particular data, I will be able to store them later on into a CSV file. And then later on, I can go to Arduino IDE, I can write the program. But important thing is, you need to use this data to train your model. And as I told you that you need to go to the Colab environment of the Google Colab, write your own code. It is not possible to discuss everything that how to write the code for creating a machine learning application, but this is just an idea that most of the things are available as a hello world example. If you want to start, it comes with a ready-made example in Arduino itself for machine learning applications. You can upload your data. Here I have taken the data for punch and flex kind of a gesture. So I have created two separate CSV files for them. I want to classify whether I'm doing punch gesture or a flex gesture. So this is the graph data, and this is some of the data which we have created. And this is about classifying the data. Now, what is basically the model when we implement into an Arduino itself? You must be knowing that when we include the file into the Arduino, we include say xyz.h. If you are using Wi-Fi, we include wi-fi.h. We include some maths.h or some related numpy etc. We include those files. So when we create a model, TensorFlow converts the model into a header file, and that is basically the model which we are going to use into our program. So if you look at the code of Arduino, the first line contains include Arduino LMS ds7.h. This is the file for maybe microphone, header file for the microphone, but when you are using the model which you have created, you need to include model.h also, and that will be your machine learning model which you are running inside the microcontroller. And later on, when you are testing it for the unknown data, it will show you on the terminal itself that whether the punch has the highest probability or flex has the highest probability. So close to that, you will be able to get some data. If punch is 90%, it means that it is accurately identifying. Right now, here both the data in terms of punch and flex are almost 50. So the model is not trained well. It is, I should say, it is not at all trained. It is simply showing you the details of 50-50%. So it is just a gaze, I should say. So I think we should keep it up to here because we will have another session after the lunch break also. So this was a very simple kind of an initiative to make you aware about how you can start working for this one machine learning for embedded system and for another systems also. But I would suggest that Arduino Nano 33 BLE would be the best solution to start with. It is not a normal Arduino Nano application, but you will see that being creative, you can do wonders using the Arduino Nano 33 BLE. So thank you so much. If you have any questions, please ask. I will be able to answer your questions.
Thank you so much, sir, for very informative and wonderful session along with the screenshots of those demonstrations. Sir, there is one question in the chat box.
Okay, let me see. So there must some or other method to achieve 190% accuracy, or can we compare our available evidence and compare to some standard models available in there? The first thing is that till today I have not found any model, even by Google or Amazon, having 99% of accuracy. Most of them are having 97, 96, sometimes 98, but not more than that. If it is having more accuracy, 99%, definitely you can have that sort of accuracy, but that should work with unknown data. Say for example, I have 100 photographs of Samsung phones of different models, 100 photographs of Apple phones of different models, and if I create a model of those phones. But when there comes a new phone in the market, it's not going to work because 99% accuracy is fine for your data. For unknown it should have again a 99% of accuracy. That is what the fundamental concept behind this. So it all depends, but not at all possible, because in the world we can never make any universal model. I mean to say universal means it covers everything. So how you can collect information or the data from the world itself, that is not at all possible. So maybe it can be a kind of a geographically or maybe universally up to some extent, that is fine. But it is not possible to train in up to 99%. If it is there, then there is a question mark how it is done.
Sir, hello, sir. Good afternoon,
Yes,
sir.
yes.
So could you please tell us what is the future of AI in terms of and the future of human being? Because
It's
AI is going to replace
very,
everything.
very interesting. I mean to say,
Could you please tell me about regarding employability? Because artificial intelligence is going to replace all the in terms of employability. Could you please throw some light on us?
so your voice is very slow. Can you repeat the question, please?
Sir,
Sir,
employability point of view, he is asking, what is the future
Okay.
of AI?
Employability wise also it is good, but one thing to remember as a faculty also, we should guide our student that simply knowing the how to program for AI or how to program or write the code for data science or data analytics or maybe for machine learning application is not going to work. The very important thing is their domain expertise. That is very important. Say for example, today I have started, maybe I am very good entrepreneur into AI area and I want to make some interesting machine learning applications. I can hire any student having BCA, MCA, BEIT, computer science, MTech, whatever it is. I will pay them very good. They are able to write the code because they are efficient programmer. But until and unless you take the domain expertise of the user or the programmer, say I want to create a application which actually identifies the possibility of heart attack. Okay, by wearing the wristwatch, I want to identify the possibility of heart attack. So I need a person who can understand, having a domain expertise in terms of heart rate variability or maybe the difference between two RR interval. And when we apply that knowledge, the person should be able to having identify the creative output of outcome from that particular model. So it is not all about simply writing the code. The same scenario is happening since many years, that there is lots of opportunities in computer science and IT, but that is kind of a flooded with programmers. When we talk about AI, when we talk about data science, when we talk about data analyst, it is all about the domain expertise, having very good knowledge of mathematics, having very good knowledge of programming skills. So those who are having all these skills together, they're going to have a very good future. But if I simply rely that someone will hire me for writing the program and maybe a software developer, then you cannot relate with any of the field, whether it is AI or a non-AI kind of a computer science related applications. But if you look at the employability kind of thing, this is going to generate more employment opportunities for people, because nowadays I have seen that every company has started working on this area. If you look at Levi's jeans, if you open the US website, they are going to hire some around 100 machine learning engineers for them. Why do want to do that? Because they are creating algorithms that if they are putting a photograph of Levi's jeans onto their website or maybe an e-commerce website, when a normal user look at particular jeans pant, if they're analyzing pixel information, that whether it is going to be purchased or not, they want to predict those things. So every company is behind the user prediction, user kind of a inclination towards their products, and they want to increase their profitability. Even in case of a nurse staffing agency in United States, I've seen that in US there is a company for providing the nursing facility, or I should say they provide nurses to the hospitals, and they have different slots to book them. They are also having 10 to 20 data scientists and machine learning engineers. They want to effectively use their system everywhere. So I should say right now there is a demand of 1,000 people, but only 10 people are available for this sort of activities. But we don't need only programmers. We need a person having most of the things in terms of expertise, having specifically looking at the domain. They should have expertise into that area. Then and then they can be successful into this.
Thank
Can
you.
we use Arduino board for detection of black hole attacks with the help of Zigbee module? I'm not into black holes. I don't know much about that. But Zigbee and Arduino, it's almost like, see, there is already a inbuilt Bluetooth on the Arduino board. So there is no need to use Zigbee. It all depends how the distance or how many devices you want to connect. but I don't have any idea about black holes, so I cannot comment. But definitely you can collect the data for black hole detection, and if you have some sufficient data, you can try to predict some of the activities based on that. That's what I can understand. What is the future scope of electronic students who mostly learn hardware? I'm from electronics. I sent my daughter for electronics also, and she's also bachelor's and right now doing master's. So personally, these days people see that like there is a less requirements or the job markets for the electronic student, but it is huge because these software companies are also like moving in some of the hardware areas specifically for automobile industries, for medical sciences or device detection, and most probably they are going to have some sort of embedded industry which will going to flourish. So in case of VLSI, even like Qualcomm today making a chip which is basically an AI enabled, they want to predict in advance that whether it is going to work well or not. So Qualcomm is working on again in a data analysis and data science part. So every company is finally transforming their domain expertise in the products which uses Lenskart app uses AI for selection of spectacles. Yes, they have some sort of AI, not exactly what AI is all about, but they have created some similar concepts like that you can wear and you can test and it actually fits. So it is something related to augmented reality, not more than that. But definitely when you are using Amazon shopping app, any music app like this Spotify or Amazon Music, they're highly AI enabled, AI enabled, I should say.
Sir, this is Trimurti. Sir,
Yes, sir.
can you compare AI and Tiny OS?
Tiny OS and
Yeah. What is the difference? But both are same, I think so. So, what is your suggestion, sir?
basically, when we talk about a specific operating system for embedded system, they are basically a kind of a real-time operating system, I should say, RTOS kind of a thing. But when we are talking about the firmwares in this sort of Arduinos and everything, they do not have much capability like the real-time operating systems. But NVIDIA has come up with a very good board having a GPU capability, having real-time operating system. So when you want to expand the power of your AI applications, definitely this sort of RTOS will help you. Because normally it's not going to cover multi-threaded operation, multi-memory management, or maybe kind of a number of applications running together. When we are running an Arduino, it's going to work on a single thread. It is not like an operating system. So it does not require that sort of real-time or a tiny OS. But definitely there are of the board by which all these big companies like Texas Instruments and Nvidia and even this one
So, comparatively,
Arduino too has one board. I don't know.
sir, comparatively, ML is more powerful than Tiny OS. Am I right?
Yes, that is. But see, right now the most of the dominant market is on this sort of tiny machine learning based application, not still into the tiny OS kind of a thing, because not much applications and APIs are available into those area. There are specifically definitely few examples available for tiny OS, but not much I have seen so far.
पण नाही का त्या अशा काही दोऱ्या आणल्या होत्या बघ आपण त्या
Participant, please
Those
be
who are
on
working
mute
in
mode.
X.
Thank you, sir.
Yeah.
Okay, thank you.
Sir, there are a few more questions
Yes, please.
in the chat box. How much data set required to train the model?
There is no specific thumb rule. Important thing is, I should say there should be sufficient data. Sufficient, we can have never any limit for that. But the only thing is that once you know that, okay, when you add up much more data, again the model improves. But at some point of time, your model will get saturated. It's not going to, whether you provide 200 images more or maybe 1 GB of more images to your model, sorry, the training data set, it's not going to change your efficiency, the efficiency of the model. It means that now the data is saturated, no need, because most of the data are like similar or duplicate or something like that. So it all depends. When you want to create your first application, you can start with some 200 photographs. Say for example, I want to create a dog and cat classifier. If I show a photograph of the dog to a camera, it will be able to identify that. So I can use 200 photographs. But if I show a different photograph which is not there in the data set, and if even though my model predicts well, it's going to say that like it is a kind of a good efficiency. But important thing is, the data you have, more the truth you have. But again, it depends what sort of platform you have for training those. If I answer you like use 1 GB of data, it would be the best solution. But you do not have that sort of hardware facility which you can. So it is all about a kind of a compromise sometimes, that having 200 photographs you can try. It is all about building a base, and then finally improvement is required. So as a beginner, we should not focus on initially the what is the model accuracy, but initially we should be able to focus on whether we are able to complete the process or not. Then improve the data, increase the data, try to improve the model, again get increase the efficiency, and later on you will come to at some point of time you will be able to see that you have done very well in terms of performing of the model, performance of the model.
Yes, sir. Sir, somebody is asking about any reference book to start with the ML.
Uh, Depending upon your interest, see, there are a number of options, and that is why I tell everyone that if you will first of all try to look at the scenario of AI, machine learning, deep learning, you will see that there is a complete book on statistics for machine learning, there is a book for linear algebra, there is a book for this one. You may start with statistics, maybe you can take 2 to 3 months, you will not be able to do anything. It is better to decide your target and goal and see that somebody will start learning Python sometimes, and again they ended up learning the Python, but they are not able to write the application. So the best thing is that simply target what do you want to do. If I'm interested in this sort of tiny machine learning, I will buy an Arduino, I will refer the book directly how to start programming on that device. I will load the sample code, and based on our experience and capability, we will be able to modify those things, and finally we can come up with a new application. Definitely, as a professor, to teach something, we should get number of content which is required for learning all this. So looking at the perspective of professor, we need to refer number of books, prepare the content for the students. If you are interested in for some of the research topics to guide to the student, or maybe for the PhD, or maybe for master's thesis, we can definitely take any of the area and we can start working on that. Let me give you an example that Spotify में तो हमने देखा था कि like it suggests you number of songs, but do you know that your choice is something like where there is a guitar content in a song, you like those songs very much, but this Spotify never understands those things. Even Amazon Alexa does not understand all this. So you can create this sort of recommendation system for your model, and finally you can deploy those things. You can identify whether there is a guitar content in the song or not using the spectrogram and all these things. So I think it is not possible to discuss everything
Yes.
to this sort of session.
Sir, I'll share your number with the participants. So
Yeah,
if
yeah,
they have
definitely.
any personal questions, they can discuss
sir.
with you. Yes. So, sir, यहाँ पे रुकते हैं हम. We'll proceed for lunch break. We'll start our
Okay.
next session at 1:30.
Okay, thank you.
Thank you so much, sir.
One request. Will you please share your PPT, sir?
Yeah, I will share.
Yes,
I
sir.
will share all the
Yes.
PPTs.
Sir, हमेशा share करते हैं. Don't worry.
Fine.
Yes.
It was very nice session, sir. Fine.
Yes.
Thank you.
Thank you, all of you. Thank you. Now I'm ending the meeting. I'll start meeting at 1:15. Yeah. Thank you, sir.
Thank you.